Hello students, today I am going to teach you about the next part of the chapter, physical quantities and measurement. So let us start. If you remember, we have discussed about density in the last module. Now I am going to tell you about density of liquids. Now, how do we measure the density of liquid? We need to know two things always to calculate the density of any substance, that is mass of the liquid and the volume of the liquid. Generally, we measure the liquid's mass by using the beam balance or the physical balance, and we measure the volume of the liquid using the measuring cylinders or cans. Now, what will be the procedure? I have just written in very simple language the procedure to find the density of a liquid. You have to take an empty beaker and it should be completely dry. You have to find the mass of its by using a beam balance. Then you have to take a cylinder, measuring cylinder. Generally, let us assume it is 100 ml measuring cylinder, and we will put oil of 100 ml, that is same as 100 centimeter cube. And so the volume of the liquid that we are going to measure is 100 cubic centimeter. That is, here the liquid is oil. Then we will pour the oil in this beaker and then again measure it in the beam balance. So we will get a new weight or a new mass, as we can say. And then how do we calculate? So suppose I say that the mass of the empty beaker was 40 gram, and after putting the oil in the beaker it became 80 gram. So what will be the mass of the liquid? It will be 80 minus 40, because 40 is only of the can or the beaker, so 40 gram. And volume, as I had already told, I had measured and taken it, so it is 100 cubic centimeter. So the formula of density for the liquid here is mass of the liquid by volume of liquid. Here my liquid is oil, so I have written oil. So 40 gram by 100 centimeter cube, which I can solve and get 0.4 gram per centimeter cube. This is how you can find the density of a liquid. Now, there's another term that we need to discuss here is relative density. Here we will be speaking about relative density. Now, the density, as you know, is mass by volume. Now, what is relative density? The density of a substance with respect to the density of water at 4 degrees Celsius is called the relative density. And it is also the ratio between the density of a substance and the density of water at 4 degrees. And this is also called specific gravity at times. So you might be assuming that relative density is not same as density. It is not simple m by v. It is density of one substance by density of another substance that is taken as a standard here, water, at 4 degree. And why I am telling water at 4 degree? Because we all know that at 4 degree the density of water is 1 gram per cubic centimeter. So that is taken as a reference. And then if in short I am writing RD, that is relative density, and it is not having any units. Why? Because it is a ratio between the density of a substance by density of water at 4 degree. If we know the RD of the substance, we can calculate the actual density of a material. So what will be the formula? If we know the RD of any substance, we just need to multiply 1 gram per cubic centimeter to convert the density in gram per cubic centimeter, or we can multiply the RD of the substance with 1000 kg per meter cube. Now let us find out the relative density of a liquid. Here we are going to use a special instrument called the Hydrometer, or the specific gravity bottle, or the RT bottle. Now it is a small glass bottle with a glass topper, and there is a capillary tube. Now how does this bottle help? What will happen is, this is specially designed bottle. The diagram may not be exactly same of the specific gravity bottle, but it is more or less the same. So when I put the liquid and put this dropper, the extra water or the liquid which we are going to find the density, the extra water will ooze out, and then we can dry the outer part and weigh this bottle and find out the density, find out the volume, and then ultimately by finding out the mass and volume we can go to find the density. So what will be the procedure? The first procedure is that you have to take the RT bottle, that is the relative density bottle, and measure it. First see that it is completely dry and clean, and measure it with the help of a beam balance. So you are calculating the mass. Then you have to fill it with the distilled water and measure the mass again. I've just simplified the steps for clear understanding. And then you have to fill the liquid of whose you have to find the relative density, and you have to measure it again. You will get the mass. So here, if I am assuming the mass of the empty bottle to be m1, when nothing was there, only that RD bottle was there, it is m1 gram. If the bottle and the distilled water together measures m2 gram, bottle and the liquid measures m3 gram. So the distilled water is it is m2 minus m1, because only waters we can then find. And if we are wanting to know the mass of the liquid, then we can minus the mass of the bottle and liquid from the empty bottle's mass, so it will be m3 minus m1. So here we can finally come to a formula which says that as volume is same for water and liquid, because we have put it in that relative density bottle, so the mass will be different and the volume will be same, which will cancel out. So we are left with mass of the liquid by mass of the water, which in this case was formula m3 minus m1 by m2 minus m1. Again, I will tell you, it does not have any unit because it is a ratio. There is another kind of a instrument through which we can find the relative density, which is called the hydrometer. Now it is, again, I have made a simplified diagram of a hydrometer where you can see the three parts. The tube is there with some graduation, a glass bulb and some lead shots to make it heavy. So it is generally made up of a glass, and it is having a cylindrical stem with a bulb weighing it or keeping it light with the help of mercury or lead shot, which will help it to float in any liquid that we put. So by putting it in a glass of water or in a glass of any liquid, it will float, and as it will float, the point at which the surface of that liquid in which we have put this, it will touch the stem, and it will point to some graduations which are here, and then we can know what is the specific gravity directly. And also, lactometer is a special kind of a hydrometer for measuring the density of milk, and there are many such hydrometers available for specialized work. And lastly, I would like to show you a simple numerical in which, through the help of the formula that I just told you, we calculated the relative density. So here the question says that the density of aluminum is 2700 gram kg per meter cube. 2700 kg per meter cube. So what is its relative density? So you know the formula, it is density of substance by density of water at 4 degree. So we know that at 4 degree it is 1000 kg per meter cube or 1 gram per centimeter cube. So this you should know because this is taken as a standard. So according to the question, density of substance is 2700 by 1000, which reduces to 2.7, which tells the relative density of aluminum is 2.7. Thank you.